Hello, pre-algebra. Sorry I can't be with you today, but here we go. I'm going to leave you with a little bit of an extension on the stuff we've already been doing with Pythagorean theorem. Hopefully by now we're starting to get a handle on it, most of us. If you're not, keep sticking with it. It can't get any harder if you're not understanding it. So all it can do is get easier if you'll keep working at it. So I'm going to, I know this feels probably like a long assignment that I'm just dumping on you, but I'm going to go through some of this with you and do some of these problems as examples to help you understand what you're supposed to do on this page, and then turn you loose with the rest of them. So we'll get several of them done here together, and then I'll let you take over. So here we go. I'm moved down. I'm going to start on number 3. I feel like it's a little easier to kind of see what's going on with number 3 than it is if I start with number 1 or 2. It just shows up a little better on this one. So we want to find the length of this line, and we're not going to get out a ruler or measure anything. That's not what we're doing. We're using the Pythagorean theorem. And well, how can we use the Pythagorean theorem, you might ask? Because we need a right triangle in order for this to work. We need an a squared plus a b squared equal a c squared. And if all I have is one line, then where do the rest of the parts of the equation come in? Well, I'm glad you asked, because it actually is there if you haven't already seen it. Here's what we can do. We can make a right triangle to fit with this line, and this line is going to be our hypotenuse of the right triangle. All we got to do is use the lines on the graph. So if I could just dot these in real quick, use that line, and here is our right angle. And so all I have to do is now, guys, you have to count. We've struggled a little bit with counting in some of the last lessons, so I'm hoping this is going to go okay. But all I've got to do is count. I want to know the length of this line, so I'm going to count 1, 2, 3, 4 units. This one is a 4, and then this one's going to be 1, 2, 3, 4, 5, 6, 7 units. So that's a 7. All right, and now I can just plug these two numbers in as the a and b. So it's going to be 4 squared plus 7 squared equals c squared. And we have talked about this before. If you take your calculator and do 4 squared plus 7 squared, boy, something didn't work right. Sorry about that. Okay, let's try that again. 4 squared plus, oh, this calculator is no good. 7 squared. Okay, sorry, your calculators will do it. My calculator will not do this because it is, I guess, not programmed correctly. Let me open up a calculator here real quick. Oh, come on, where are you at? Well, that's not okay. Applications. Goodness, sorry. Calculator, there we go. That. Okay, and sorry, I can't get it to where you can see everything on the screen. I can close this. All right, there we go. This calculator should do it. This should be programmed correctly. So if I do 4 squared plus 7 squared equals 65. That's correct. So then I would be able to write 65 equals c squared, and then we take the square root of that, and now my calculator disappeared. 65, and if we just hit the square root button, which is that one, it comes out to 8.06, yada, yada, yada. So I just want to round it to the nearest tenth, so it's 8.1. So 8.1 is the length of this line segment. We're going to do a couple more of those. Sorry about that. I didn't realize the calculator in the program I used was not a good calculator. So I think I can do this maybe. I should restart my video, but I'm not going to. Let's get rid of that. Leave. Oh my goodness. Okay. All right. Now can I open up the calculator? Oh, it disappeared again. Okay. All right. I think I can manage now. You guys are seeing me fumble around on video. All right, here we go. Let's just do, let's just do number 4. Number 4 is going to be okay. Move over here so we can do that. So again, I want to just make my triangle a right triangle, or make my line the hypotenuse of a right triangle, I guess. And this one, this distance here, obviously is going to be 1. And this is 1, 2, 3, 4, 5. So I can do 1 squared plus 5 squared equals c squared. Okay? And I can just type that straight into my calculator. 1 squared is 1 plus 5 squared. 5 squared equals 26. So 26 equals c squared. Take the square root, and square root of 26 is 5.1. So my answer here would be 5.1. I'll tell you what, we're going to box those so we can see them nice. Okay, some of you, I'm sure, that are doing okay with Pythagorean theorem are already like ready to move on. That's fine. Keep going. I'm going to do a couple more of these for the people that are struggling a little bit. If you are struggling, just hang in there. I'm going to do what I can for you. Okay, so let's do this one. We've got to draw in. You don't have to draw it if you can just count it, but we're going to draw it in so you can see what I'm counting here. So I'm going to start here at the top corner, and I'm going to count down 1, 2, 3, 4. And then I'm going to start here at this corner. I'm going to go 1, 2, 3, 4, 5, 6. So that's 6. So 4 squared plus 6 squared equals c squared. And so that would be 16 plus 36. 16 plus 36 would be 52 equals c squared. Take the square root. So square root of 52 is what I'm after here. And that is 7.2. So we would call the length of that line 7.2 units. We're not measuring in inches or meters or centimeters or anything. We're just measuring in units. Alrighty, let's do number 5. So there's my line. And that would be 1, 2, 3. And then 1, 2, 3. So 3 squared plus 3 squared equals c squared. Well, that would be 9 plus 9 is 18. So 18 square root is 4.2. Alrighty. Oh, let's do 1 or 2 more together, and then I'll turn you loose to try it on your own. Draw this in. This was going to be 1, 2, 3, 4. And this one is 1, 2, 3, 4. So 4 squared plus 4 squared equals c squared. And that would be 16 plus 16 is 32 equals c squared. 32 square root is 5.7. Since that's a 5, we would round that 6 up to a 7. So 5.7. And let's do this last one here. I think by now, hopefully you're seeing what we need to do. We need to start off. And can I do something, I don't know, crazy? Can I count it from this side instead of the bottom? Oh, does that just confuse the heck out of you? Hopefully not, because it's just the same thing. It doesn't matter. I could go this way too, and it'd be the same thing, okay? So it doesn't matter which way you go when you draw your box in. You can go down like this, or you can go up like this. Either way is fine. So 1, 2, 3, 4, 5, 6, 7. And then this is 1, 2, 3, 4. So 4. That would be 4 squared plus 7 squared equals c squared. So 16 plus 49 would be 65 equals c squared. I think we already saw that number, didn't we? I don't know why this program duplicates itself so much. 65 square root. That's 8.1. Yep, we've already seen that answer, 8.1. So anyway, hopefully it's making sense. It's really simple. It's the same formula we've been using for a week now. It's just a little different application, and you've got to kind of come up with those measurements on your own by drawing in the rectangles and then counting. But I feel like we ought to be able to count. So we will, I know some of you will be gone Friday because of choir trip, but most of you should be here. So we'll spend some time on this Friday, and then going over more Pythagorean theorem stuff. And then Monday and Tuesday, we'll probably look at getting ready for a quiz on Pythagorean theorem. And then Wednesday of next week, we're going to do fast bridge testing. So that's kind of the plan for the next 3 or 4 days of class that we'll have. All right. Hang in there, guys. I will see you on Friday.